subnet, okay, before they come out and say that they want to do according to the subnet, they have already assigned a lot of the IP addresses to many different big companies like IBM, Google, Yahoo, okay. All of them have a very big range of IP address that belongs to them. So it means a lot of address has been gone to waste. Okay, it's not used by anyone because it belongs to the company. So what they do next is they try to solve this problem, okay, by first using the CIDR, meaning the subnet calculation, the calculation that we do yesterday. Alright, the calculation that we do yesterday. Okay, so they try to use this CIDR to reduce the number of empty addresses so that they can assign more addresses to people. And then they have this DHCP. So DHCP, they give you the address automatically. Alright, once you connect, okay, once you connect into the network, then they will automatically give you a address. Once you get off, once you turn off the device, you turn off your Wi-Fi, then your IP address will be taken back by the DHCP server and they'll give it to other people. Alright. And then they also have the NAT. What they'll do is, remember we have the private address, okay, the private addresses in this here, the class ABC, we all have the private address range, okay, all of this. So all of this private address, alright, 10.000 until 10.255.255.255, okay, this range here, all of this range, they will not be processed by our internet. Okay, they will not be processed by our internet. When our internet see this range, they will not do anything. So, but then our PC is now using this range. Okay, we are using this range in our PC. So how does it work? It's because of this NAT here. What this guy will do is, it will help to translate our address, okay, from the private to the public. Okay, they will try to translate our address from private into public. Okay, so this is what the NAT is trying to do. Okay, so we have CIDR, the subnet calculation, to help us reduce the size of our networks into something that is more make sense. Then we have the DHCP that assign IP when the connection is, when the device is up, and remove the IP and take it back and give it to somebody else when the device is off. And finally we have the NAT, which help us to translate from private address to public. So when they translate from private to public, okay, it means that it allows us to have a lot of devices using the same public address. Okay, it will allow us to use a lot of devices to use the same public address at the same time. So this chart here, okay, this chart here shows that when the IPv4, okay, is actually running almost finished. So around our Asia, okay, we in Asia have used up a lot of IP addresses. Okay, the blue color, this blue color here is actually our IP addresses. We have already started at so low in 2013. In fact, in 2011, our IP addresses is already almost finished. Okay, that's why you see this coming down flat like this. Okay, does IPv4 have CIDR or not? I just mentioned a few times. CIDR is the same as the calculation that you do yesterday. Now you ask me again.
ชอบว่าแบบเจ๊
the subnet calculation. Okay, see the subnet calculation. All of this, we calculate /21, /22, /29, all of these things. Okay, this is what we call CIDR. All right, they are the same thing, just different name. CIDR, subnetting, okay, same. So in 2011, okay, our IP is already finished. What's the difference between public address and private address? I explained it yesterday. Let me explain again one more time. Please remember, this private address, okay, all of this address, when the internet router, the routers in the internet, yeah, the routers that runs all the internet, that brings our packet from our PC to the servers, okay, that allows you to connect to my Google Teams, Microsoft Teams, okay. So all of this address is not seen by those router. I repeat, the router, when they see this range of address, all the internet router, when they see this range of address in the packet, they will not do anything to the packet, meaning they will not forward the packet, they will not route, they will not send the packet. When they see this packet, okay, with this destination IP, they throw it away. Alright, if they see this destination IP, that is any destination IP that is in the private IP address range here, they throw it away. Alright, this is the main difference between public address and private address. Private address can only be used in LAN, okay, in our LAN network. Alright, when you connect to Wi-Fi, okay, when you plug in cables in the office, okay, all of this is because we can immediately use internet because we use the private address, and then we have the net, we have this thing, the net here, okay, this net here, to help translate from our private IP, the private address, into the public address. Now if we take a look at here, let's take a look at the machine here. So one way to find out what is your public IP, very simple. Okay, so over here, let me just set it back to automatic. Okay, so over here you can tell the IP is 1.218. Okay, over here is 1.218. This is second one, the second PC. Okay, and then over here this guy is 1.220. Okay, 1.218, 1.220. Both of them you open up the Wireshark. Go to google.com.
Cái phát hiện hiện châu là ticket chậm. Cái phát hiện hiện châu ticket chậm mà.
Okay, go to google.com. Very simple. Just type my IP address. Okay, my IP address. You will see, okay, even though both of them, okay, both of this PC, alright, they are using a different private IP here. Okay, this is 218 and then this one is 220. Okay, they are using different private IP here, but you can see the public IP is the same, 110.4.40.60. Okay, 110.4.40.60. Right, they are the same because we use the NAT, okay, to translate the IP, to convert the IP from the private, from this one, the private IP, into this one, the public IP. Then only they send out. Alright. Now the details about how this thing works, okay, we will cover later in the afternoon today. For now, understand this, yeah? So whenever your packet goes into internet, they must be changed into the public IP first. And after they change to the public IP, then only they can move to the destination on the internet. So the problem of the IPv4, okay, the problem of IPv4 is first, there is not enough address. Alright, there is not enough address. Second, there is no support for mobile devices, okay, for mobile hosts, because in the past when they create all of this IP, okay, there is not even a device called laptop. Okay, laptop does not even exist at that time. So there is no concept about mobile host. The address, okay, the address is not in hierarchy. Okay, it doesn't have a hierarchy for the address. Meaning, today when you get an address, let's say 5.0.0.0 network, it can be belongs to US, and then later you get 6.0.0.0, which is belongs to China. Then tomorrow you get 7.0.0.0 is under US again. Okay, it's very messy. So there is no hierarchy on how the address is assigned. Limited support for real time, especially voice and video. No security mechanism inside as part of IPv4. Legacy components in the header that aren't used. So there are some parts, some of the header some of the field in the header we don't even care about. Okay, nobody actually look at it anymore. Okay, so all of this needs to be changed, and that's why they came up with the IPv6. So from IPv4, in IPv4 we have 32 bits in binary. Alright, we have 32 bits in binary. Okay, we learned about this yesterday when we do the calculation. There is a total of 32 bits in IPv4. In IPv6, there's 4 times more. Okay, total 128 bits. Alright, total is 128 bits. So how many address can this IPv6 handle? I don't know how to read. Okay, this many. Alright, I have no idea how to read this, but this many addresses. Okay, and with this many addresses, alright, with this many addresses, so now we can actually give every device in the world, okay, with their own address. Okay, we can give any device in the world with their own address without require to separate, to convert from private address to public address. Okay, we don't need that anymore, so we don't need the NAT. Okay, so this is very useful, especially for now when everybody wants to go for IoT. Okay, there are more and more IoT devices, like for example GPS tracking with that you can access using your apps. Okay, for your car, the GPS tracking on the car that you can use, you can check on your phone. Okay, all these kind of devices, security camera, okay, CCTV, TV, okay, smart switch, all these kind of things, okay, they can all be assigned with an address. Now this is an example of an IPv6 address. Okay, this is how it looks like. So in an IPv6 address, the address will be in hexadecimal. Alright, it cannot be decimal value anymore because too many, too big, very difficult to calculate. So they use it in hexadecimal. Alright. So hexadecimal value is from 0 until 9 and then A until F. Okay, so what they do is, like for example Facebook, they try to make it more easier to identify. So for Facebook, their address, they make it like this. So after the address at the front, all the numbers, hexa value, then they have a face, FACE, and then B00C. Okay, Facebook. This is what they do. Some companies will do something like this. Alright, but then again, it depends whether you can get that IP or not. Any question so far?
Không chưa.
Okay, no question, then we go forward. Alright, we now look at it, the upper layer. So remember the data inside the IP packet. Okay, So remember, over here, okay, we have also data over here. Okay, the protocol over here, what they do is they tells you the content inside this data. Alright, so we know that we will be looking at like things like TCP, UDP, ICMP, all these things. Right, these are our data in the IP header. So inside this data, alright, we also have another header again. So now we are going to look at those header here. So let's say inside this, just now, if the protocol says that the content of data is UDP, then you will have a UDP header. So in UDP header, you will have first port number, okay? You will have a source port and destination port. Alright. So again, in Ethernet, we have MAC address, source MAC address, destination MAC address. In IP header, we have source IP address, destination IP address. In UDP header, we have source port, destination port. So this port here, okay, the source and destination port over here, what it can do here is, alright, this port, it allows you to identify the application, okay? It allows you to identify the application. So over here, this source and destination port, they allows you to identify the application. Like what application is running, is what application is using this data, okay? Which application should I give it to? Alright. Then we have the length field over here that tells you the total size of this whole thing, okay? The whole thing over here, from the header until the content, the data, the total size of everything. And then they have the checksum, again for error checking purpose, to make sure that there is no error. And finally, the data, the content, okay, the files that you send, the email that you send, all those things. If let's say, okay, if just now in the protocols field in the IP header, they say that this is on TCP, so what you get is now a TCP header. So in TCP header, same thing, you have the source port and destination port. Okay, source port and destination port. Okay, and those is the port for identify application. But now in TCP, there are more extra things. So they have what we call a sequence number over here. So remember, we mentioned that when you send all those packets, okay, when it reaches the destination, they might actually reach in a wrong order. Okay, when you send packet that is too big, okay, so they will be chopped into multiple small parts. So when they reach the destination, okay, they might actually be in the wrong order. Okay, they might first you send it as 1, 2, 3, 4, and then finally when they receive it like 1, 3, 4, 2. So they need to rearrange all of those packets. Alright. So this sequence number here tells them the position. Okay, the sequence number. Then we have the acknowledgement number. So sequence number again, to ensure that all of your application when they receive, it will be in a correct order. Then we have the acknowledgement number, okay, to acknowledge the message. Right, later we will see in detail what it means. Okay, so by using the sequence number and acknowledgement number, it helps us to make sure that your packet is being sent and received in a reliable method. Okay, you will always be able to receive your packet completely. Then we have the data offset, which is actually the length, the size of the TCP header. And then over here we have some pointer depending on what it's actually going to do. Like if U, it means this is a urgent. Okay, if it's A, is acknowledge. So if you have an acknowledgement, if this is an acknowledgement message, then they will send an A. Okay, P is telling them that not to buffer the received data. R is to reset connection, S establish connection, and F release connection. So later we'll look at it, okay, in detail about all of this. Then we have the window size for the flow control. Error checking, checksum. So then this urgency pointer, okay. So let's say if this is the last piece of the data, okay, this is the last piece of data, okay, and everything is, you have no longer have anything that you want to send, okay. So they will have this urgency pointer enabled here. They will have a value for the urgency pointer. Okay, so when they're using this urgency pointer, okay, this U over here will also become value 1 to tell you that there is an urgency pointer. Okay, so what happened is, if my PC saw this urgency pointer over here, so what my PC will do is I will immediately pass the data to the application. Okay, and finally we have the data. So in UDP and TCP, okay, we look at a bit of difference between the UDP and TCP. So in UDP, okay, UDP is a unreliable protocol, okay, unreliable connectionless protocol. What I mean is, when UDP try to send data, okay, when UDP tries to send data, if we send data using UDP, okay, their job is very simple. I try to do my best to send it to you, okay, but whether you receive it or not, I have no idea and I don't care. Alright, that is UDP. In TCP, this is a reliable connection oriented service. Okay, so what the TCP will do is, I will make sure that you receive what you want. Alright, I will make sure that you receive what you want. Okay, because if you don't receive what you want, then I fail. Alright, so TCP will try to make sure that you will always receive what you ask for. Okay, all the data that you want from by using TCP, you will always receive it. So now in TCP and UDP again, since UDP is not reliable, okay, since UDP is not reliable, usually when we use UDP, okay, we do not use it to send big data, okay, big size data. We don't use UDP, we always use TCP. Alright, because UDP can anytime something just go missing. So if you put them in different parts, so when they reach your destination, one of the part go missing, your file maybe cannot open anymore. Alright, so we want to make sure that when we send, we try to send as more as we can. Okay, there is no acknowledgement in the UDP, and your data, when they arrive at the destination, they can be in out of order, meaning not in the correct order, and the application also will not do anything. Okay, so when application receive it, it is still out of order, in the wrong order. Okay, so this kind of protocol, the UDP protocol, is only usually suitable for something that needs to be sent very fast. For example, our voice over IP. Why do I say voice over IP? Very simple. If you think about it, when you make a phone call, okay, when you make a phone call, and when you're talking to another person, if let's say during the phone call, it might be a little bit unclear, okay, maybe one of the words that your friend is saying, okay, gone missing, cannot hear. But most of the time, okay, even if you have lost the voice, what you will do is you just ask him to repeat. Right? Just like yesterday. Yesterday you say that there is one time that my connection not good, so you just ask me to repeat. Okay, that is much easier. Alright, because if you don't allow it to repeat, if you use TCP, what happens is TCP will, because TCP will always try to make sure everything will be received by the destination. So what they will do is they will try, if they don't receive it, they will try to ask for it again, and then until they receive it. Okay, so until they receive it, it might take some time. Okay, it might take some time. And if you use it for phone calls, alright, for voice, what happens is you might be actually wasting time to just waiting for the message to come. Okay, just waiting for the message to come completely. Alright, so that's why we don't use TCP in the voice over IP. TCP, what they do here is they are good at making sure everything is correct. So especially when you need to have a connection, a good connection, to make sure everything will be received by the receiver, okay, by the destination. So this kind of application will be things like, for example, HTTP, the website. When you browse website, you want the website to load completely. Okay, you want to see everything on the website. You don't want to like reading the article halfway through, then one or two paragraphs gone missing. Okay, there are two paragraphs gone missing, then you can't continue to read because maybe it doesn't make sense anymore. So what TCP will do is it will take a little bit more extra time, make sure that everything received, then only they show it in the application for you. Alright, so usually like for example, also like files, download file, download video, download movies. Okay, when you download movies, okay, what happens is you are downloading everything into your PC. So if let's say some part of the file, of the video file, okay, is missing, alright, if you use UDP, that means your file is not complete and you might not be able to play your video. Okay, even though you have, let's say the file is 10 gig, you already download 9.9 gig, but the 100 megabyte is just cannot, it's missing. Okay, so what happens is then you waste your time to download all those files, while at the same time you still cannot use it. Okay, same thing for like things like SSH or SMTP. SMTP is your email, SSH is the for you to manage your devices, the routers. Okay, all of these are they need to be very reliable. They want to make sure that when the receiver receive it, they receive everything, okay, with nothing missing. So that's why they have to use the TCP. So again, in UDP, they do not rearrange the order. okay, when your data comes in, when your packet comes in wrong order, UDP will keep it like that, okay, they don't do anything. TCP, they will put back into correct order. So let's say if you receive it as 1423, then it will actually try to put it back into 1234 in TCP. Any questions so far?
Any question so far? Hello.
Any question? Cười quá. Ấy à, tôi được cô này ấy à, dù gì tin đi.
No question. No. No.
Okay, no question that we look at here. UDP and TCP. So we already know, okay, in our data, okay, at the very beginning of our course, we already mentioned. First, when your application create the data, all right, then we have to go through the process called encapsulation. So from the top layer, it goes down, okay, they will add in a header. When it goes down again, they will add in another header, goes down again, add in another header, then only they send it out. And when they receive, they will have to remove the header one by one. So this is how it looks like. When your data, okay, when they create the data, this is your data, right? This is the application data. So in the application itself are the data, right? So what the first thing they will do is, during the encapsulation, they will have to add a header, which is called the TCP header or UDP header, depending on which one you are using. If you use TCP, then TCP header. If you use UDP, then UDP header. Right? So they have to add this header here to tell the receiver, okay, to tell the destination PC, okay, which application is supposed to actually process this data. Okay, because remember, our PC do not know each other. Okay, my PC and your PC is different. What I create in my PC doesn't mean that you will automatically know. Okay, you will not be able to know what is the data that I send to you. So I need to tell your PC what application is actually supposed to use this data. Like for example, if I'm sending an email, so I need, this will be the email port numbers, okay, so that when you receive it, you know that, okay, this is actually an email data. So I need my Microsoft Outlook to open up the email. So after they add the TCP and UDP header, they also have to add the IP header. Alright, they also need to add the IP header. So IP header is the one that gives us the IP address. Okay, we use the IP address to do all the sending here and there, okay, to talk from here in Malaysia to you in Cambodia. Alright, this is because of IP address. IP address allow us to communicate with each other. Okay, so they send our data, allow us to talk to the globally. And then in Ethernet, they have to add another layer, which is the Ethernet header. So in Ethernet header, you have the MAC address. Okay, we use the MAC address over here to talk to each other, so that at the very least we know that who is the local device that we can talk to. Alright, the locally device. So you need to be local. Ethernet header is all about the physical connection, the local. Everything must be in the same network, that only you can talk to each other. Alright. So again, you have the data, and you have the TCP UDP header, and then you have the IP header, and finally the Ethernet header. So in Ethernet header, there's one more part, which is the checksum, which is basically they take all of this from start in the Ethernet header all the way to the data, okay, and then they calculate, use an algorithm to calculate, and then they store the value inside here to check, make sure that when the receiver receive, okay, the packet, and then when they check, is there anything missing, is it corrupt? All right, so this is what they do. So over here, so we know that the port number is used to identify application. Alright, so now we look at it in a little bit details. Now, because our device, okay, the device that we are using nowadays, okay, doesn't matter what device, your phone, okay, your tablet, your laptop, your PC, the servers, okay, they are all multitask, okay, they are able to open and run multiple applications at the same time. For example, you could have a web browser, a Google Chrome, and then the Firefox, and then Microsoft Outlook, okay, all at the same time. Okay, so this is what we call by multitask. So to allow your PC, okay, to talk to other devices on the application separately without any problem, each of the application is always assigned with a port number. Okay, each application here, all the application here will be assigned with one port number. So the source port number, okay, the source port is the application that is sending the data. So let's say if you try to browse google.com, okay, you type www.google.com in your browser and press enter. So in that case, you are sending a data here to the Google server with the source port of your application, the web browser, Google Chrome. And then you have a destination port, okay, which is the application that is supposed to receive the data. So again, just now when you type google.com, you press enter. So you will have a source port of your PC, the web browser itself, the application web browser, okay, port number as the source port, and then the destination port will be the web server destination port, because you're telling the server that I want to browse your web page. Okay, I want to browse your web page, so they are sending a destination port for that web page. All right. Now daemon over here is basically program, okay, programs that runs on the server. So what they do is they are constantly waiting, okay, listening and waiting for all this data that you send, okay, so that they can respond back to you. For example, I'm trying to browse server, so I'm actually sending a message, a data to the web server here, but who is the device? Who is the application here? Application is actually the daemon. All right, the daemon is the application. So when I send a request, say that I want to browse Google web page, so you send all the way until this server here, and then server will pass it to the daemon, right, the application that is actually waiting, listening. So once I receive it, then okay, I will reply back with you and give you the web page, right, so that you can actually read the content. Right, so same thing, okay. So when you browse from your PC to the Google website, alright, so on the browser type google.com, so automatically your PC will assign a port number. So what you do is you put in the destination port number, destination IP, alright. So how they write is you have the IP first, then you have a colon, and then you have a port number. Okay, after the colon is a port number. So if you try to browse Google, then you take Google IP address, and then colon port 80, Okay, and this will brings you to the Google Web Server. Alright. So when the server replies, it will reply back. Now the destination port. So when they reply back to the application port number here. So in this case 23456. Now there are many applications. Alright, there are thousands of applications in the world. Okay, all of these applications, there are a lot of them that use a specific port number here. Okay, to make it easier for our life. They make it standardized. So if you look at SSH, it will always be using TCP on port 22. Okay, if you're using a browsing website, HTTP, it will be always be port 80 using the TCP protocol.
No.
If you want the secure version HTTPS, then you have the 443 port number and using the TCP protocol. Right? So there are some, like, for example, SNMP is using UDP protocol. Okay? So depending on the application that you use, right, each of them have their own port numbers. Okay? What I mean by using these port numbers here is, if let's say, okay, you try to browse a web page. If you don't use 443 as the destination port number using TCP header, okay, what happens is when they receive the destination receive it, okay, this is not TCP 443, so I don't care. So they are not able to actually give you the page, okay, unless you use the same port number as the server.
Socket is
So over here we have the TCP three-way handshake.
Okay,
so in TCP, alright, before they start sending anything, alright, they need to talk to each other first. Take note, yeah, this is important. Okay, very important. So in TCP, okay, they will do this. So at the first, you tell them, okay, I want to send. What happens if you use UDP on 443? UDP on 443. So if there is no application is actually listening, waiting for the UDP on port 443, then nothing will happen. It means you will just get, let's say you tap on browser, okay, then you will not be able to browse the page at all. Okay, whatever application they're using, you need to use back the same port number as the server. The server says that they are using port 443 on TCP for website, then you have to use the same. Okay, if the server says that I'm using HTTP TCP port 80, then you must also follow back HTTP port 80. Alright, if not, you will not be able to browse. Same thing, if the server say I'm using TCP port 80, then you must follow back TCP port 80. Okay. So you cannot simply just swap between TCP and UDP, yeah. So like for example, unless okay, like for example over here some they have TCP and UDP configure, both also can. Then yeah, then you can use UDP port 80. Okay, if they don't have configure that, then cannot. Okay, just like that. Yes, follow the server port. Okay, server tells you this, then you must follow. Okay, so over here we have our client and server, okay, our PC and the server, source and destination. So before they start to talk to each other in all those HTTP SSH telnet all those things, okay, before they can actually talk to each other, the first thing they do is they need to talk to each other using the TCP first. They have to send a message, okay, what we call a sync message. Alright, so if you see here, what happened is the source, the client here, is trying to send a message and tell him my sequence number is this, okay, and this is a synchronized message, a sync message. So what it means is, hi, I'm Darren, nice to meet you, okay, this is what they're trying to do. Then the server, okay, the server will send back a message here, okay, to introduce himself and also acknowledge what you have said. So what the server is trying to do here is, oh, hi Darren, so your name is Darren, my name is Jason, okay, so this is what the server is trying to do here. So he sent back this message to the client here. So in this case, they will have a sync value and also an acknowledge. Okay, they send their own message, they send their own sequence number as a sync value, and at the same time they acknowledge the previous message that I sent to them. Okay, and then the client, when they receive this, okay, when they receive this, then he will send back the same thing again to the server and say, oh hi, so your name is Jason, okay, then they send a acknowledge over here, okay, so they acknowledge what the server sent to him. Alright, so this is what we call the three-way handshake. Understand? So after they have acknowledged, okay, after they introduce themselves, okay, after they finish introduction here, then only they can have a proper connection. They will establish a connection, and from there, okay, they will start sending data. Alright, so every time there is a data being sent from, doesn't matter from server or from client, all the data must be acknowledged. Okay, all data will be acknowledged. Okay, so if let's say in this case, in this example, the server send the data for the client. The client will send back an acknowledge message, say, okay, I received your data. Then the server send another 2 more data over here, and then the client send back another message, 2 more messages here and say, okay, I received your data. Alright, so this is what they do. So when everything is finished, okay, when everything, all the data transfer is done, no more data to transfer, okay, then the server will send back a message and say, okay, I'm already done with sending your message, okay, all the data that you want I sent to you already. Then the client will say, okay, understand, okay, so they will have a send a finish over here, they will send an F finish over here and acknowledge at the same time, and the client have to acknowledge back to the finish. Okay, then from there they terminate the connection, then they no more, they don't talk to each other anymore. Until next time when they want to send again, then they repeat the same process again.
Any questions so far?
in TCP, all right, they have their own algorithm to try to make sure that the data is always going to reach you. Okay, you want to try to make sure that the data that they send to you is always will received by you. So what they do here is okay, this is something simple in a simple explanation. So when the data is sent, okay, let's say from the source they send to destination, right, and then from the destination they send it back to the source for the acknowledgement. Okay, so in this case the source here, the PC over here, they have to acknowledge again. So when they send the acknowledge, right, okay, so every time here, if you see the numbers here, you see there is a countdown, right? Every time when they send the message, all right, they are expecting a acknowledge message from the destination. So let's say my PC send a message to the server, so I'm expecting that the server will reply me back with an acknowledgement. If I do not receive the acknowledgement message within the time that I have set, okay, within the timer, so what I will do is I will send back again. But if I receive it, yeah, everything is normal. Alright, if I receive it, then everything will work as normal. So if let's say I don't receive it, this is an example. If I don't receive it, so when I try to send a message, okay, the timer here is running, alright, and then they are supposed to send back me the acknowledgement. And when let's say this message that I'm waiting for, okay, I'm waiting for that message, but somehow it just go missing. It doesn't come to me again. So what I will do here is this PC here will try to send again and wait for the acknowledgement again. Okay, so if this time I receive it, yeah, then everything will be fine. Continue as usual. Alright, if this time still fail, then okay, I will try to send again, and then send again, until finally when I receive the message that I'm waiting for. Okay, when I receive the acknowledgement from you. Until here, any question?
No, sir.
Okay, so until here, alright, so this is how our TCP works. So in TCP, again, everything must be acknowledged. Whatever you send, they must acknowledge. They must tell, okay, I receive. Okay, I receive. Alright, so that the destination server knows that, okay, you receive it. Okay, this is how the TCP makes sure that you will always receive your data. So there's another protocol which is what we call the SCTP. So SCTP, Streams Control Transport Protocol. This is mostly used for telco, okay, to do signaling over the IP networks. In the past, when you use the PSTN network, you use SS7, okay, but now since everybody, even telco, is starting to move into mobile network, into IP networks, alright, everything needs to use IP, so they need a method and they need something to carry mobile data. Okay, so TCP not very good, UDP also not very good, so what they do is they create their own, which is called SCTP. So it's similar to TCP, very similar to TCP. Before you start, it will also requires a handshake process. Okay, before they start sending any data, they will also need to talk to each other first. Okay, they need to have a handshake first, like saying hi, nice to meet you. Okay. The difference here is in TCP, okay, every time when you send data, it's only one flow, okay, one stream of the data. But HTTP, you can have multiple streams of the data at the same time. And they also guarantee the order of the packets within the same stream. So when the receiver receives the data, they will always be in the correct order. Okay. Then they also acknowledge message similar to TCP, but not the same, just similar. Okay. And this SCTP is used by the service called SIGTRAN, signaling transport, okay, to provide a transport service to SS7 signaling. So what it means is that now you can actually use your SS7 signal, okay, on the IP network by using the SCTP protocol. So if TCP IP, right, this is how they send the data. In TCP IP, okay, they send like a small pipe, just one pipe, one flow, they just send. Okay. If let's say the packet for call 2 is lost, alright, call 1 and call 3, those that is behind this packet loss, alright, will have to be delayed, okay, because they need to wait for the retransmission. Okay, they need to wait for the machine over here to send back the data again. So over here will be delayed. But if it's SCTP, okay, if it's using SCTP, they are all separate in different layer, okay, in different stream. So if you have for the first call going on, okay, the first call will just go on. If call 2 have a packet loss, the loss this message here, okay, the delay only happens for call 2. Alright, others are not affected at all. So this is the main difference between SCTP and TCP. And then we have the RTP, real-time transport protocol. So what this RTP do is they allows you to send real-time message, okay, especially for our voice and video. So this is mainly used by when you use for VoIP or voice over LTE, okay, VoLTE. So when they use this RTP, okay, they are actually still using UDP. Alright, RTP here is like something like the application, like HTTP, SSH, all of those. Okay, this is the another different one, which is called RTP. So in the RTP, what they do here is they will have a header that provides a payload type ID, okay, which tells you things like, for example, the codec that is used. Okay, if you're using PCM as a codec, then it will tell you the value. If you're using G.722, okay, there is another value. Alright, just to tell you what type of codec is using inside this RTP message, so that when the receiver receive it, they can use the same codec to decode the message. So they also have the sequence numbering, and they will also have a timestamp, okay, to make sure that the packets, okay, the time between the packets can always be stable.
Packet data.
And then we have the RTCP, real-time control transport protocol, okay, to send packet stream. Right. So RTP is the one that actually sending all the audio and video data RTCP is the one that sending on the control the data for the controller, okay, like what you want to manage, all kind of things, okay, the packet count, the jittering,
logical
the round trip
IP
time, all sorts of things, okay,
the
the
logical
QoS,
IP
this is sent by the
មានតែក្នុង
RTCP.
ហ្នឹងគេកំណត់ IP ហើយវាមាន data បញ្ជូនទៅរបៀបម៉េច application
I assume no question.
អត់យល់ទេ no ទៅដាក់ no មួយទៅអត់ចេះហ៎អូមកលុបហាត់ឯកុំ no សួរចុយម៉ែឡើយ no
If no questions, then we will continue with a small exercise first. Now section 4 we will not do now, okay, we will do it later. So let's go to the next part, section 5. In the exercise of page 48.
48
okay, in page 48.
ចុះនេះភាពឲ្យចេះអត់នេះអា sweet ស្អីណានេះឡាឡាហើយក្បាល
So now if you go to
មិនចលុំហាត់តល់មកកណ្ដោ
yeah, so if you go to your PC, okay, please go to your PC. We need you to use the PC now. We need you to use the lab machine. So on the lab machine, I need you to open up the activities here. You go to the files, okay, you need to open up a file, okay, you need to use that file to do this exercise, okay, go to files and then open the desktop folder, okay, open the desktop folder. There is this file called tcp/con.pcap. Double click and it will open up the Wireshark. Okay, this is a Wireshark record. Okay, double click on this file and this will open Wireshark. So what you need to do is, based on here, all of this, you need to answer the questions, the empty space here, fill in all the blank. Alright, you need to fill in the blank. Okay, I repeat. Open up the files. Okay, once you open, go into the desktop folder. You will have this tcp/con.pcap. Open the file. Okay, and it will open the Wireshark for you. Then you can find the information by double click inside here.
Yes.
Okay, in all of here, all this information, okay,
yes,
from TCP, IP, Ethernet, all of this. Alright, you use all this information here to answer the questions in this page.
Yes.
Okay,
client.
Use
hot client,
the
hot client.
Wireshark to answer all the questions in this page. Alright. Now over here we have the time over here. Okay, this time over here. So the time is referring to here. Okay. So we need to calculate them in milliseconds. So you can do this, set it as millisecond. So in your Wireshark, time display,
Cái này đấy.
Okay, time display you can choose milliseconds. Alright, and then this will be the time in millisecond. How many milliseconds? Alright, the 0 here, 0.000 here is means that 0 second. Okay, millisecond is the value at the back here. 049 means 49 millisecond. Alright, 049 here means that 49 millisecond.
Alo.
Okay, even if you do not use the, if you do not change, then the first three value here is the millisecond. Alright, so like for example over here is 49.2 millisecond. Okay, so just answer the questions according to this Wireshark. Everything is inside this Wireshark here. Right, everything is inside this Wireshark here. Okay, so this is the question.
Mình là boss ngắn cyclone này thò mà chết tất cái giáp mà.
For those who don't have the book, okay, bear with me, you will have to see this more, okay, because it's very big. For those who have the books, please do it in your book. Alright, we will discuss this later. So try to do this question first, okay, before we go for lunch.
Linux rất client cho vào những oi tại chắc khăn lõi cục tình kia ấy mà destination Cisco software nè mà nó là port client muối nè cho mình nhà muối nè thì nè xin tới ô nè anh port của trạm miên này cái đang server client 74 cho nó frame với cái
bằng bon đã trái lại nó kèn đâu cả
port chứ
để cho do millisecond là số chọn một vị bảy
port bất cứ port port đó đây port bình thường thôi chứ ô nè destination portរបស់ server អានេះគឺ port របស់ client ណា soft port មានន័យថា port ដែលយើងបញ្ជូនទៅ destination មានន័យ port ដែលយើង request ទៅត្រូវអត់ចឹង soft port គឺមានន័យថា port client server វាត្រូវជូនត្រឡប់មកវិញIP client តើរក IP client សិនយ៉ាងហោចណាស់ក៏បានខ្លះដែរព្រោះអាណាចេះយើងចេះទាំងអស់ចេះបាទមួយហើយចុច address ហ្នឹងdestination server client đây phi kì đã đó hả 120 lúc à người bị đôi khi ở trời khôngគ្នាsau tư khơi nhỉ khôngគ្នាnè chân thờ nam mùi từ vô là thờ nam mùi từ bây giờ click bị server nên này nó đào tuần sọc đợi trong cái máu ra chân client này server này trong hồ bị server nó chỉ sọc trầm trời ok vứt thường bình wow trời thoảng này ơi bình rồi lấy số nó ơi bình này mùi bị bay buồn đòn đọc bay hiệp hay mở cái pin hồi hỏng bấy môi cho mà hồi đầm bớt rồi hồi bình bớt lên thêm hồi đầm bớt vì miền server ai click tới can server vì miền server cho mình đăng ha môi na server môi na ấy đo đại mơ HTTP cứ chỉ protocol xong qua server nè sync hay nâng sync acknowledge nên này bà chun thấy server mình bà chun mau mình tôi vô vào xây vào vì đâu cho ngay mình thử còn bao tiếng ớt thử ra kịch thoảng bao những ớt kịch ra port rồi bọc client port port mình khơi port ba chai lấy tờ hồ mình click bật đây có nghĩa là port soft port destination port trong port của bot client cứ 4 và mỗi 24 chứ nhưng từ server với port biết thằng này transmission protocol port thì bỏ ao cho thưa rắn ngồi với tình nghĩa ra nè port for server cứ phải sập vậy theo ao thưa nó ngồi với tình nghĩa ra nè hè một mu lý đạ trở lại ớt ọt này tham nè nó tham tới đó là tham và chun SEQ cái SEQ mình nên đây thầm e nhiên SEQ bên đây thầm bài từ vô là vô một đôi chặt tê lon chứ mà nè bị chun thế nó bị chun bập nên nó bị chun từ lọt mà bình nó là tập nó bị chun là này tao bình
tí bố nên tí đó đã mấy với nhỉ
rồi cái má nè thế nha sang như lon không mà từ ok đã
HTTP toàn đăng ấy bông toàn thợ đo nâng hòn ớt ban snap cô bây giờ là cái lại nâng hòn cái lại chọc vậy mùi mì
SEQACK khả năng cái trong mà này cái gì nó gì thế thằng mấy SEQEK nữa giỏi chứ
លោកខ្លាចអញថតនឹងសោះថតអត់ឃើញខ្លះ
ឃើញតែប៉ុណ្្នឹងអា
server ដល់80ឯង តែខ្លាចអញថតដល់ណា
ថតនឹង54 6 54នោះសិននៅភាពអីយ៉ាងនេះតែខ្ញុំនេះSEQ នឹងអីគេអាពាក្យពេញឯង S ផ្លេច
អូអា AK អា AK គឺជូនទៅជូនមកណាជូនពីវារុញ
រុញទៅរុញមកតែវាមិនដឹងអី
អាណាថតពីថតខ្លាចអញទៅគឺអូតូបន្តិច
0x 002ផ្លេចរបស់ client ផ្លេចរបស់ចុយផ្លេចរបស់ server ទាំងអស់អញយល់ហើយញ៉ាំញ៉ាំ
ពេញវាពេញវាណាហើយអញចូលចូល
មាន12ជូនមកជូនទៅជូនទៅជូនមកខ្ញុំដងមួយអាចគោអីចឹងអូយ server សិនផ្លេចរបស់ server អូនេះ ASQ ASQ នោះមាននៅលើ server តា ASQ
អូឡំវិញឡំវិញគឺ
CC ធម្មតា ASQ ឆ្លោះ acknowledge សួរត្រូវធ្វើខំមិនទៅ
Okay, guys, it's already lunchtime, so if you want to, you can go for lunch first. All right, we will come back at 1:10. Then you can continue to do your work.
Yes.
All right, so we'll discuss later.
I'm not hungry yet teacher
No.
Yes, you
Come
can
back
continue to do first.
2 o'clock
You can continue to do first.
yeah just kidding
không mà 2 o'clock នេះ
ចង់និយាយថាយើងកំតអាវឃ្លានបងយើងសុំគ្រូចូលម៉ោង 2 វិញ
The more late that we continue our class, the more late our class will end today. So you choose. You want 8 o'clock to end the class? Can.
yeah we can 10 also they can 10 o'clock also
Okay, so we'll discuss this exercise around 1:30.
okay
Okay. So you want to eat first, you want to do first, up to you. Okay.
Thank you teacher
After, by the way, after you finish this page, okay, you also need to finish the next 2 pages here. Until number 15.